Hello everyone, and welcome to Mitchell's Crash Course in Physics. Let's look at our first question. An inquisitive physics student and a mountain climber climbs a 48-meter high cliff that overhangs a calm pool of water. He throws two stones vertically downward, 1 second apart, and observes that they cause a single splash. The first stone has an initial speed of 1.96 meters per second. We're going to start by looking at part A and solving for how long after the release of the first stone do the two stones hit the water. So we're solving for the time it took for both the stones to hit the water. Next, we're going to draw our picture so we can get a visual of what's going on in this problem. We have our physics student, our cliff, the water. We have our first rock here with its labeled initial speed and a little farther down than the second rock because we know it was thrown 1 second before. Then we have our second rock with its unknown speed. We have the height of the cliff, and we have our coordinate axes calling down the positive direction and towards the left the positive direction. Next up, we label our givens for rock 1 and rock 2. Now, the only difference between rock 1 and rock 2 is the initial speed, but we'll get into that in just 1 second. First of all, the accelerations will be the same because both the objects are in free fall, meaning air resistance is negligible and they have a constant acceleration of 9.8 meters per second. Their change in position is also the same because they're both falling from the same place, or from the same height, you could say. The only difference is the initial speed because we are only given the initial speed for rock 1 and we're not given any speed for rock 2. Next up, let's look at some of our graphs that we made. The first one we're going to take a look at is the acceleration versus time graph. As you can see from our givens, it carries over to our graph. Both rock 1 and rock 2 have the same acceleration throughout the whole time. The only difference is that rock 2 starts after 1 second, not at 0 seconds. We're going to look at our velocity graph in a minute for part B. Next, let's look at our position versus time graph. We have rock 1 and rock 2. We know they start at 48 meters because that's the initial position from where they're dropped, and they reach to 0 meters because 0 is what we're calling ground level or water level in this case. We know that they hit at the same time, but rock 2 starts after 1 second. Okay, now on to calculations. We have a lot of calculations here and it might look intimidating at first, but after this step by step, trust me, it's gonna be easy, don't panic. We're gonna start with our kinematic equation. Change in position equals the initial speed multiplied by time minus 1/2 acceleration multiplied by time squared. What we're going to do first is set our equation equal to 0. To do this, it's simple. We just subtract the change in position, so make sure we have 0 on this side and minus delta y over here. We can even simplify this equation a little farther before we start plugging in numbers. We know that the change in position can also be called the final position minus the initial position. As we stated before, we know the initial position is at the top of the cliff, and we know the final is at the bottom, which is also considered to be 0. So it's 0 minus 48 meters for our change in position. We also plug in our acceleration, which is negative 9.8 meters per second. And then we plug in our initial speed, which is 1.96 meters per second. After that, we're going to clean up our equation a little bit. We take half of our acceleration to get rid of that fraction, and then we're going to subtract 0 minus 48 to get our change in position totally. All that's left is to rearrange the equation from descending order. So 4.9 meters per second squared times time squared plus 1.96 meters per second times time minus 48 meters. After that, all we need to do is plug this into our calculator and solve for t. Since this is a quadratic formula, you get one negative and one positive answer, but we know that time is not negative, so we're going to go with our positive answer for today. That way, we solve for the time it took for both the stones to reach the water, which is 2.94 seconds. Thank you. Next, we're up on part B. What initial velocity must the second stone have if the two stones are to hit the water simultaneously? This time we're looking for the magnitude, so the speed and the direction. Let's start with the direction because it's the easier question of the two. We know if we're dropping the stones off the cliff that the direction is downward, and simply that's our answer. The direction is downward. Now let's go look at our givens now that we've found the time it takes for the stones to reach the water. For stone 1, we know it takes 2.96 seconds. But for rock 2, we know it takes 1.96 seconds. But how do we know that? Well, we know rock 2 is thrown 1 second after rock 1. So by subtracting that 1 second off of the time, we get how long it took rock 2 to reach the bottom. Now we're going to take a look at our velocity time graph. As you can see here, rock 1 starting at 0 and slowly going until it reaches final position. But that with a smaller slope than rock 2 has, because rock 2 starts 1 second later but reaches the same position at the same time, which means the slope has to be greater because it's going faster. Now let's take a look at our equation. Once again, we're going to use the same kinematic equation. Change in position equals initial speed multiplied by time minus 1/2 acceleration multiplied by time squared. Simply, we just have to plug in all of the givens and all the things that we found. We know -48 for change in position. We know the time for rock 2 is 1.96 seconds. We know the acceleration is 9.8 seconds. And once again, we know the time is 1.96 seconds. All we do from there is plug it into our calculator and solve for the initial speed, which is 15.3 meters per second. And that's all. Easy peasy lemon squeezy. Now we're on part C. What is the speed of each stone at the instant the two stones hit the water? First, let's take a quick look at our givens. We now have plugged in our initial speed for rock number 2. And then we can go right to the equations. This time we're using the first kinematic equation, which is also the easiest and the simplest to do, especially now that we have all our givens and knowns listed. So we have final speed is equal to the initial speed plus the acceleration multiplied by time. From there, we plug in the initial speed we were given, we plug in our acceleration of 9.8 meters per second squared, and we plug in the time we found from part 1. Then we plug it into our calculator, and we get the final speed for rock 1 was 30.9 meters per second. Rock 2 is the same process, but we use the numbers from the given for rock 2. So, we know that our initial speed is 15.3 meters per second. Our acceleration is the same, it's 9.8 seconds. And we know meters per second squared. And then our time, which is 1.96 seconds. And then we plug that all into our calculator, and we get the final speed of rock 2 is 34.5 meters per second. I would just like to thank you for listening to this video.